Then welcome to my channel. In this slot, we're going to discuss another essay question for SPM 2021. All right, so that will come out in Section C, question number 11. All right, so the essay will be determining the heat of displacement. All right, before we move on to the heat of displacement, we try to check few example of short essay question. All right, student must remember the main definition for heat of displacement, heat of precipitation, heat of neutralization, heat of combustion. All right, so please remember bond breaking reaction is endothermic reaction. Example is given. Please memorize all these in the module. All right, and bond forming reaction is an exothermic reaction. Please remember all these example of bond forming reaction and bond breaking reaction. And please remember all the objective question. Cold pack, please remember ammonium nitrate and one more potassium nitrate. All right, please remember ammonium nitrate and one more potassium nitrate. All right, so an hot pack, please remember hot pack, sodium, calcium chloride, magnesium sulfate, anhydrous copper 2 sulfate, anhydrous potassium chloride, magnesium chloride, and sodium acetate. All right, we move on to the first short essay question. Please check this question. All right, they give experiment 1 or set 1 and set 2. Here they use hydrochloric acid. This hydrochloric acid is a strong acid, and here they use ethanoic acid. This acid is known as weak acid, and the heat of neutralization for this one is higher. All right, so the heat of neutralization for experiment or set 2 is lower. All right, so this reaction is known as exothermic reaction because the heat of the reaction carries negative symbol. It is released to surrounding during the chemical reaction. The heat energy that absorbed during bond breaking reaction is lower than the heat energy released during bond forming reaction. All right, so we check the answer for this one. Please check this one. Hydrochloric acid is a weak acid, strong acid. Ethanoic acid is a weak acid. So how to answer? The answer is given. Why? Explain the differences. We check the question. Explain the differences in the heat of neutralization between set 1 and set 2. So how to answer? The heat of neutralization in set 1 is higher than the heat of neutralization in set 2. Hydrochloric acid used in set 1 is a strong acid, while ethanoic acid used in set 2 is a weak acid. Ethanoic acid ionizes partially in water, producing lower concentration of hydrogen ion, while hydrochloric acid ionizes completely in water, producing high concentration of hydrogen ion. Thus, during neutralization in set 2, so we discuss set 2. Alright, we discuss set 2. Heat is released and some of the heat is absorbed, okay, or used to further ionize the molecules of ethanoic acid. So student can get 5 marks from here. Alright, we try to check this question. Alright, so we read the question. Alright, so table shows the heat of heat release for experiment 1, 2, and 3 for different acids react with sodium hydroxide. So this is known as heat of neutralization. Please remember, heat of neutralization is an exothermic reaction. Alright, so we try to check the question based on the table 8. Table 8 explain the differences in heat of heat release between experiment 1 and experiment 2. So experiment 1, experiment 2. So here is higher. This one is higher. This one is lower. So the answer is given here. Please check the answer is given in the module. Alright, so next one. We try to check the experiment 2. I try to do experiment 1 and 2. 1 and 3. So experiment 1, they use hydrochloric acid. Alright, so experiment 3, they use sulfuric acid. Please remember, hydrochloric acid is known as a strong acid, and the basicity is known as monoprotic acid. Alright, so next one, sulfuric acid, please remember, is a diprotic acid, and the heat of neutralization for these two, experiment 1 and experiment 3, is same. Alright, so we have to answer this question. So I do here experiment 1 and experiment. Alright, experiment 3. So we check point 1, the heat of neutralization. The heat of neutralization of experiment 1 is same as the heat of neutralization of experiment 3. Alright, so we put here experiment 3. Alright, so we already score 1 mark. So point number 2. We go for point number 2. Hydrochloric acid used in experiment. Experiment 1 is monoprotic acid. Monoprotic acid. Why? Sulfuric. Sulfuric acid used in experiment. Experiment 3 is diprotic. Diprotic acid. For this we will score another marks. Point number 3. Hydrochloric. Hydrochloric acid. Acid in experiment. Experiment 1 will ionize. Ionizes and produce. Produce 1 mole of hydrogen. Hydrogen ions. Okay, while sulfuric. Sulfuric acid in experiment. Experiment 3 will ionize. Ionize and produce. Produce 2 moles. 2 moles of hydrogen. Hydrogen ions. Alright, so we go for point number 4. Point number 4 in experiment. Experiment 3. In experiment 3. So here we must do ionic equation. Ionic equation. So I try to do chemical equation first. Sulfuric acid. So we check experiment 3. We check experiment 3. Sulfuric acid react with sodium hydroxide. So we try to do sulfuric acid react with sodium hydroxide. So we will get sodium sulfate plus water. So we balance the equation. So here sodium 2. So I put 2. Then we check the hydrogen 2 plus 2 4. So here I put 2. Alright, so we need to do ionic equation. So in this reaction we take a hydrogen ion. So we have hydrogen ion. We have 2 hydrogen ion. 2 mole of hydrogen ion. So here we have 2 mole of hydroxide ion combined produce 2 mole of water molecule. So we need to write this one. We need to write this one here. Alright, in experiment 3, when 2 moles of hydrogen ions reacts with 2 moles of hydroxide ions to produce 2 moles of water molecules. So when 2 moles of hydrogen ion react with 2 moles of hydroxide ion to produce 2 moles of water molecules, the heat of neutralization still same as the heat of neutralization of experiment 1. Alright, so next we go for this is point we go for point number 5. This is because the definition. So we follow the definition of heat of neutralization. Definition of heat of neutralization is based on the formation of 1 mole of water molecule. So these are the answer that students should write in the exam. So I go through again all the points that student must remember. First point, why the heat of neutralization between experiment 1 and experiment 3 is same. So we check the heat definitely. So the answer will be the heat of neutralization of experiment 1 same as the heat of neutralization of experiment 3. Why? Because hydrochloric acid used in experiment 1 is monoprotic acid, while sulfuric acid used in experiment 3 is diprotic acid. Hydrochloric acid ionizes in experiment 1, ionizes produce 1 mole of hydrogen ion, while sulfuric acid in experiment 3 ionizes to produce 2 mole of hydrogen ion. Alright, so in experiment 3, when 2 mole of hydrogen ion react with 2 mole of hydroxide ion, I follow this one. 2 mole of water molecule is produced. So here 2 mole of water molecule is produced, but the heat of neutralization still same as the heat of neutralization of experiment 1. Why? Because this is because the definition of heat of neutralization, okay, is based on formation of 1 mole of water molecule. Alright, please check question number 11. So all this I already discussed in previous video. Please go through everything, all the chemical equation and how to observation, what is the function of polystyrene cup, why the initial temperature is taken after a few minutes, why the zinc powder is added, in excess and how to do calculation, all these discussed already, so please check. And this is heat of displacement. Please remember this is heat of displacement. All right, so next targeted question for structure will be heat of neutralization. Please check all these already discussed in the previous video. Please check all the videos. All right, so and next one, please check this one is heat of combustion. All right, so in this slot we will discuss essay question. All right, please check this question. We try to check this question. All right, so we try to read the question. All right, so the reaction is given here. So this is known as when silver chloride. Please remember, silver chloride is insoluble salt. It will form white color precipitate. All right, so this is known as heat of precipitation. All right, so heat of precipitation. When we check the value, heat of the reaction gives negative symbol. That means, please remember, this is exothermic reaction. So this is known as exothermic reaction. First point. All right, heat energy. Heat energy is released to surrounding. All right, heat energy is released to surrounding. Energy, total energy content. Please remember, total energy content. Content of reactant. Reactants is higher than total energy content of the product. All right, products. All right, and one more point, please remember the heat. All right, so please remember the heat energy absorb during bond breaking. All right, bond breaking. Please remember, always remember bond breaking. Bond breaking reaction is known as endothermic reaction. Endothermic reaction. All right, please remember one more, bond forming reaction is known as exothermic reaction. Bond forming reaction. Okay, heat energy absorbed during bond breaking is lower than heat energy release during bond forming reaction. So all these points must remember when this is endothermic reaction. Now read the question. All right, now we try to read the question. So draw energy level diagram. So we need to draw energy level diagram. Please remember this reaction when we have negative symbol, heat of the reaction when we have negative symbol, arrow going down. Okay, how to fix this one? We turn right here, turn left here. So this is known as energy level diagram, and this energy level diagram, here put reactant, here put products. All right, so I try to draw energy level diagram for this reaction. So here we label energy. So I put here energy. So we take the ruler, we try to draw arrow going down. All right, so once we put arrow here, all right, once we turn arrow, we see the arrow turn right. So I turn right here. All right, so here turn left. All right, so this is the energy level diagram. So please write down the reactant here. So the reactant, silver ion plus with chloride ion. Follow the ionic equation given. So reactant is here, and here we will get silver chloride, and the heat of the reaction is given between the reactant and product. So we put here heat of the reaction negative 65.5 kilojoule per mole. All right, so next question. Explain the differences in the energy level energy content of the reactant compare with the product. So the answer already written here. Please check the answer. So we can put here the reaction is exothermic. All right, so we can put here comma, the heat energy is released to surrounding. All right, the total energy content of reactant is higher than the total energy content of the product. So we can write down this point. All right, we can write down this point number one. And one more point that students should write, the heat energy absorbed during bond breaking. Bond breaking is lower than the heat energy release during the bond forming. So this point also we can write. Okay, any 2 point we can write all these points. So we already score 4 marks here. So please practice, please go through this question. All right, so try to check this question. So we try to read this question together. All right. So here they give reaction number one, reaction one, reaction two. Diagram one shows the energy level diagram of two chemical reaction. So here, based on this table one, deduce, compare, and deduce information that can be obtained from the energy level diagram. So we try to gather the information. So here we have a positive symbol, heat of the reaction. Here is a negative symbol. So this reaction is known as endothermic reaction. Endothermic reaction, heat energy is absorbed from the surrounding. So here heat is absorbed from the surrounding. So this is the first point. Second point that student must remember, the temperature of the surrounding decreases. When temperature of the surrounding decreases, and please check here, this is known as reactant, and this is known as the product. So this is known as product. All right, so the energy content, total energy content of the reactant is lower than the products. Okay, product is higher. All right, all these student must remember. And one more that student must remember, so this reaction is known as endo reaction, endothermic reaction. Endothermic reaction means heat energy is absorbed from the surrounding. And when endothermic reaction, please remember, endothermic reaction stand for bond breaking reaction. So therefore, in this reaction, bond breaking, the energy absorbed to break the bond is higher than the bond forming, the energy that released to bond during the bond forming reaction. So all these points student must remember. So we go for reaction number two. We check reaction number two. So when we have a heat of the reaction negative symbol, so this reaction is known as exothermic reaction. So exothermic reaction, please remember, it is released to surrounding. So during it, it is released to surrounding, the thermometer reading or the temperature increases. And please remember, this is reactant. The total energy content of reactant is higher, and the product is known as lower. And please remember, when heat is released, when heat is released to surrounding, the reaction is called exothermic reaction. And exothermic reaction is, please remember, bond forming reaction. Okay, bond forming reaction. That means heat energy released during bond forming reaction is higher than the heat energy absorbed during bond breaking reaction is lower. All these points should be written in the answer. So we try to answer this question. So we need to compare and deduce the information that can be obtained from the energy level level diagram given. So reaction number one, please remember, this is known as endothermic, this is known as exothermic reaction. So first point one, the reaction is endothermic reaction. All right, so where the heat energy is released to absorbed from the surrounding. So here I put the reaction. The reaction is exothermic reaction. All right, so we go for point number two. So the thermometer reading in this reaction. So I put here the thermometer reading thermometer reading decreases, or student can write the temperature of surrounding decreases. All right, so here the thermometer reading increases, or we can write the temperature of surrounding increases. All right, point number three, we have to deduce information based on the total energy content of reactant and also total energy content of the product. So here I put the total energy content of reactant. Reactant is lower than the total energy content of products. All right, so point number three here will be the total energy content of reactants is higher than the total energy content of products. All right, so we put like this. All right, we move on to the next one, point number four. All right, I go for point number four. All right, we go for point number 4. We have to talk about bond breaking and also bond forming. So here, please remember this reaction is absorbed. When it is absorbed, the reaction, please remember, is endothermic. Endothermic reaction, please remember, bond breaking. Bond breaking reaction is higher compared to the bond forming. So how to answer this one? The heat energy. The heat energy absorbed during bond breaking. Breaking is higher than the heat energy. The heat energy release during bond forming. So here is the answer. So we move on to this one. Please remember, when it is released. Okay, when it is released, the reaction called exothermic. Exothermic, please remember, is known as bond forming. Bond forming reaction will be higher than the bond breaking. So how to answer this point reaction? So the heat energy absorbed absorbed during the bond breaking we put here is lower than the heat energy release during bond forming. All right, so these are the answer that students should write for the in the exam. So I go through everything one by one. All right, point number 1, the reaction is endothermic. Heat energy absorbed from the surrounding. If student want to write, can. The heat energy reaction is exothermic. So the reaction is exothermic. Heat energy released to the surrounding. Point number 2, the thermometer reading decreases or temperature of the surrounding decreases. The thermometer reading increases. The temperature of the surrounding increases. All right, so next point, the total energy content of reactant is lower than the total energy content of the product. Total energy content of reactant is higher than the total energy content of the product. All right, and point number 4 will be the heat energy absorbed during bond breaking, which is endothermic reaction, is higher than the heat energy released during bond forming. So here the heat energy absorbed during bond breaking, which is endothermic reaction, is lower than the heat energy released during bond forming reaction. Try to check the essay question under thermochemistry. So this question can come out in section C, question number 11. So the essay question, we try to read the question. Okay, you are provided with 1.0 mole Dm-3 of copper 2 sulfate solution with zinc powder. All right, describe one experiment to determine the heat of displacement of zinc and copper 2 sulfate solution. So in your description or must consist of procedure, okay, method of calculation, heat of displacement. So we check the apparatus. So try to check the apparatus: plastic cup or polystyrene cup, thermometer, measuring cylinder, spatula. All right, material that needed is copper 2 sulfate solution, and I use zinc powder. All right, procedure, we measure and pour 25 cm power 3. This one we can change it to 1.0 mole Dm-3 because in this question, so they put 1.0 mole Dm-3 of copper 2 sulfate solution, okay, into a polystyrene cup or plastic cup, up to student. All right, so record the initial temperature of copper 2 sulfate solution after few minutes or after 3 minutes. All right, so next we go for add 1 spatula of zinc powder. So this zinc powder should be in excess, okay, added in excess, and we must put quickly and carefully into the polystyrene cup containing copper 2 sulfate solution. Stir the mixture by using thermometer. Student must mention thermometer here. All right, so next one, observe and record the highest temperature of the mixture. So these are the points that students should write in the exam, if let's say this question came out in the paper 2. All right, so next we move on to the how to do calculation. So we do calculation, tabulation of data. So please do table like this. All right, so under we put initial temperature. Please check the question number. Procedure number 2, record the initial temperature of copper 2 sulfate solution. We record the initial temperature of copper 2 sulfate solution. Make sure the unit is placed here. All right, so we put a symbol T1, and the highest temperature in the procedure. So observe and record the highest temperature, so we put here. All right, so and the temperature change or theta we can put T2 minus with T1. All right, so calculation to determine the calculation heat of displacement. So first we check number of mole. We use N equals to mv over 1000. So the volume is given here and the molarity is given here, so please apply in the formula. So I put here 0.5 times with 25 divide with 1000, so the answer 0.005 mole. All right, so next we go for heat change. So please remember heat change, use mc theta. All right, so m is the total volume, the mass of zinc powder. Please ignore this, will be m. So m will be total volume 25 and c specific heat capacity 4.2 joule per gram per degree Celsius, and the temperature change, please take everything like this, T2 minus with T1. All right, so we represent with x kilojoule. All right, so this is the answer. So next one, we need to find the heat of displacement, and please remember we take the x kilojoule divide with the number of mole, 0.05 mole. All right, so we put y kilojoule per mole. All right, so please remember the reaction between zinc and copper 2 sulfate solution to produce zinc sulfate plus copper is example of exothermic reaction. Therefore the heat of the reaction must put symbol negative, so I put symbol negative here. All right, so this is the answer that student must remember. We move on to this question. Please check this question. We move on to this question. All right, so metal V and copper 2 sulfate solution. So this is known as heat of displacement, and here they give thermometer. All right, so we try to read the question. All right, I call wants to determine the heat of displacement of metal V, so I can take metal V, zinc or magnesium. All right, so by chemistry using the apparatus setup given in the diagram 10. All right, so the apparatus setup already given. So by using name of metal V, describe how I call can carry out the experiment. In your description include procedure calculation to determine the heat of displacement. So I try to do point number 1. So I try to list out the materials. So the materials will be, so I put here metal V is zinc powder. All right, so next I need copper to sulfate solution. All right, so next I'll list out the apparatus. The apparatus needed in this experiment. So I put here polystyrene cup. Polystyrene cup, please remember we must put thermometer. Thermometer is very important to measure the solution. We need measuring cylinder. All right, so to add the zinc powder, we need spatula. Please remember spatula. So all these material apparatus all is given. So we already named the metal V. All right, so next we go for procedure. All right, so we go for procedure. Procedure number 1. So we measure and pour 25 cm power 3 of 0.5 mole dm negative 3. Student can take 1.0 mole dm negative 3 up to student, okay, of copper. All right, so I put here copper 2 sulfate solution. Please put copper 2 sulfate solution into a plastic or polystyrene cup. So here I use polystyrene cup. All right, point number 2. So we record the initial temperature. Record the initial temperature of copper 2 sulfate solution. So we put here copper 2 sulfate solution. Please put after few or 3 minutes. All right, so up to students. So we put here point number 4. Point number 4, we add one spatula of zinc. So we will use zinc powder. So please remember to put quickly and carefully. This two word is very important into the plastic or polystyrene cup containing copper 2 sulfate solution. All right, so point number 4. So I put procedure number 4. So student must put stir the mixture with thermometer. All right, so next point, to mix. So here I put to mix the reactants. All right, so point number 5. Please put observe and record the highest temperature. All right, so we put here highest temperature of the mixture. All right, so these are the procedure that student must remember. So starting with material, all right, apparatus, measure the and pour 25 cm power 3 of 0.5 mole DM negative 3 of copper 2 sulfate solution into polystyrene cup. Record the initial temperature of copper 2 sulfate solution after few minutes or after 3 minutes. Add 1 spatula of zinc powder quickly and carefully. Alright, so into polystyrene cup containing copper 2 sulfate solution, stir the mixture with thermometer. Thermometer is very important. Alright, so next one, observe and record the highest temperature of the mixture. So these are the procedure. Now we go for tabulation of data. So I put your second point will be tabulation. Tabulation of data. So I put tabulation of data. I prefer to use table. So here I use table. So first point I put your initial temperature. Temperature of copper 2 sulfate solution. Copper 2 sulfate solution, the unit I will put here. So I record here, this is T1. Alright, so next one, I will try to put the highest temperature of the mixture. So the highest temperature of the mixture, so I put here degree Celsius, though this will be T2. And next one will be temperature change. Alright, so I put your temperature change. The temperature change we can put theta, so unit will be degree Celsius. So I put your T2 minus with T1. Alright, so this is the tabulation of data. Next, I go for calculation. Calculation to determine the heat of displacement. So calculation to determine the heat of displacement. First point, we need to find number of moles of copper 2 sulfate solution. So we use N equals to MV over 1000. So the molarity used is 0.5. The volume used is 25 divided with 1000. So the answer 0.005 unit will be mole. Alright, so second step, we try to find the heat change. Alright, so heat change Q M C theta. So the total volume used here is 25. C will be specific heat capacity 4.2. Then I open bracket, I take the temperature change everything. So I put here T2 minus with T1. So then I represent with X kilojoule. Alright, so and the last point will be heat of displacement. So how to find the heat of displacement? So we try to do the triangle HQ divide with N. So we try to put the QX divide with number of mole. So the number of mole given here, we already find the number of mole is 0.005. So I put here 0.005. So I get Y kilojoule per mole. Alright. So please remember, if let's say they ask chemical equation in this reaction. So how to do the chemical equation? Zinc. Alright, so I put here zinc reacted with copper 2 sulfate solution. So I will take out the ion zinc 2 positive, take out the ion copper 2 ion, take out the sulfate ion. During chemical reaction, this one will, zinc ion will join with sulfate ion. So I will get zinc sulfate plus copper. Erase the charge put here. Alright, so equation balance or not, please check the equation is balanced. Zinc 1, copper 1, sulfate everything 1, everything 1. And please remember, this reaction is known as exothermic reaction. Therefore, we must put negative symbol here. Alright, if let's say in the exam they ask ionic equation. Please list out all the particles present in the chemical equation. So zinc 1 capital 1 small exists as atom. So I put here zinc atom. Alright, so when this is soluble salt, so this is made up of ionic compound. So I take ion. So I list out all the ion. Copper 2 ion, sulfate ion. Alright, so here this is soluble salt, so they exist as ion. This is atom. Alright, so here I list out zinc ion, sulfate ion, and copper atom. So please remove the spectator ion. The spectator ion like sulfate ion, nitrate ion, chloride ion, all these should be removed. So I remove this one. I remove the sulfate ion. Alright, so here we will get zinc. We take the zinc plus with copper 2 ion. Alright, so arrow. So here will be zinc 2 positive. Plus with we take copper. So this is the ionic equation that students should write in the exam. Ionic equation. Alright, so please remember all these questions. Alright, so that's all for this chapter. So please remember all these ionic experiments. So the experiment that student must remember in this chapter will be to determine the heat of displacement, of copper 2 sulfate solution react with zinc, or copper 2 sulfate solution react with magnesium. So that's all from me. Thank you very much. We'll meet up in next slot. Take care. Bye bye. See y'all.